In this video, we're going to explore a systematic way of solving systems of linear equations. So the point is, when you have large system of equations, you really don't want to be fooling around. It's difficult. We're going to mainly be dealing with equations, three equations and three unknowns in this class. But in general, you can have a million equations and a million unknowns, even a trillion equations and a trillion unknowns. It's a serious problem. And we're going to learn the basic algorithm. And again, in practice, you would just use the computer, like use a calculator to solve algebra problems. You would use a computer to solve these. But it's important, I guess, to understand how the basic process works. And we're going to explore that in the next few lectures. So in the first lecture, what we're going to do is I'm just going to work with the equations. So here's a system of three equations and three unknowns, and I'm going to work with it in the equation form, but try to introduce you to the ideas. And don't stress too much about it, just try to go with it. There's nothing really here. It's just there's a lot of baggage when you have to write it out. So we want a more efficient way of doing these problems. And in fact, in the beginning, you're going to be rather slow. But with some practice, certainly hopefully by the end, after you've worked some of these out, you'll be able to solve these problems in really just a few minutes. But right now, what I'm going to do is we're not going to really use this, carry the equations around. We're going to be a more efficient way. But I want to introduce you to the ideas here. So here we go. We have three equations, right? 1, 2, 3 equations. We have three unknown variables, right? We have x, and again, it's linear in the x variable, right? X to the first power. We have the y variable, and again, it's linear in the y variable. And it has z, and again, linear in the z variable. If you're not linear, we're going to explore that later. It's very difficult in general to solve nonlinear problems. All right, so how are we going to solve this, right? I mean, how are we going to solve it? We want a systemic way of doing it, systematic way of doing it. We need x, y, and z, right? We have to solve for x, y, and z, and guessing isn't necessarily the best option, right? So how are we going to do it? I'm just thinking maybe there's a way that could help us do this. I mean, maybe there's a way. Oh, yes, Gauss Jordan is the way, right? That's what we're going to do. So we're going to explore Gauss Jordan elimination. It's an algorithm, essentially, okay? I mean, it is an algorithm. So basically, I'm giving you directions on how to solve this problem, the Gauss Jordan algorithm. Now, like with anything, if I give you directions to go from here to somewhere else, if you follow those directions, I'll guarantee you get there. The problem is if you start taking shortcuts. So we have to pay attention to that. That's what tends to confuse people. So let's work on the algorithm, and then whenever I deviate from that algorithm, I'll tell you that what I'm doing. So we're going to cover this. First, I just want to get the ideas across. First thing Gauss tells me to do is, for the first equation and the x variable, I want to get rid of this 4 and make it a 1. You'll see why the algorithm works as we go forward, why it's so efficient. But that's what I want to do. I want to get rid of that 4. Now, how can I do that? Look at that first equation. I want to get rid of that 4. Now, the easiest thing you think is I'll just divide by 4, and there's nothing wrong with that. If I'm using a computer, I mean, it's fine. Except if we're going to do it by hand, I did get the 1 there. But notice what I have fractions. And I don't really like to carry fractions around. I mean, you can. There's nothing wrong with it. And if you're desperate, just do it. But I don't really like doing that. So the question is there a better way to do this? So I want to get a 4 for the first equation up there and the first variable. Anything come to mind here? Any other way you think we can get a 1 up there? I mean, any other way? I'm just saying, any ideas here? Any ideas at all? I mean, I'm trying to get a 1. Hey, there's a 1 right there. Now, really, one of the things we can do is we can just switch the order of these equations, right? Just literally switch the order of the equations. And then, without any difficulty whatsoever, I have a 1 there, okay? And that's what Gauss requires me to get, a 1 right there. And all I did was no effort at all. Just switch the order of these equations. And there I have it. So that was fine. Now, this is going to be key. These ones that are going to pop up are going to be decisive, and you'll see how we're going to use it. Next thing Okay, I have the 1 there. And once I have a 1 locked in, it doesn't change. Next thing I want to do is I want to get rid of this 3. Right? That's the Gauss algorithm. Now, how am I going to get rid of that? I want to turn it into a 0. Right? How am I going to do it? Well, this is where that 1 is decisive and will play a decisive role. Okay, because look what I'm going to do. I'm going to multiply the first equation by the minus 3, and then I'll just add it to the second equation. And I want to do that in a systematic way. So we're going to multiply the first equation by minus 3. And you see, this is why that 1 will always be decisive. And that's what I get over here, right? So minus 3 times 1, minus 3. Minus 3 times minus 2 gives me the 6 here. Minus 3 times the 3 gives me the minus 9. Minus 3 times the 11 gives me minus 33. And we're going to keep our work on the right because it's obviously very easy to make algebra mistakes. So you're going to make mistakes. What we want is an efficient way of representing our work. So if you make a mistake, and you'll know it, you can come back, find it, and correct it quickly. Right? I mean, I always make mistakes, but I can find it and correct it quickly. So we're going to show our work on the right, and that helps. And I'll just bring the second equation over, right? So this is kind of our scratch work on the right. And I'm just going to add these equations right here. So I'm going to add the first and the second equations together, and I'm going to get this. So minus 3 plus 3 is 0. That's for the x's. 6 plus 3 is 9 for the y variable. Minus 9 minus 1 is minus 10 for the z variable. And on the right-hand side, minus 29. So that's it. I got the 0 where I wanted it to be. And now I'm going to take this equation and substitute it back. What I basically did is I just multiplied the first equation by minus 3 and added it to the second equation. But I'm doing all that work on the side just so I can keep track of what I'm doing and minimize the chances of making mistakes. So I put that in there. So that equation is just minus 3 times the first plus the second, and that's what happens to it. Okay, but notice I got my 0 here. And that's what I wanted. So I had a 1 on the first, for the first x, 1x. And notice I had a 0 there. Notice you can see what's happening. It's starting to slim down. The equation is getting, the system is getting simpler each time we do these operations, these steps. So now Gauss tells me to get rid of this 4. I want to make it a 0. That's what I mean by make it a 0. Right? So I want it to be a 0. So what am I going to do here? How am I going to get rid of that 4? Right? Well, the same ideas we did before. Take a second and see if you can figure out, what do you think we need to do? Right? What do we need to do? This 1 is decisive. Right? You always use that. You're always going to use that. So if I want to make this 4 a 0, I'll just take the first equation, this 1 here, and multiply the first equation by minus 4 and add it to the last equation. All right, so minus 4 times the first equation gives you this. So minus 4 times 1 gives you minus 4. Minus 4 times the minus 2 gives you the 8. Minus 4 times the 3 gives you the minus 12. Minus 4 times the 11, minus 44. So that's how I got the first one. And I'll just bring my third one over. Again, I'm really just doing minus 4 times the first added to the third one. But I want to do my work on the right, so, again, I can try to avoid making mistakes. So I'm going to add these two equations together, and I get this. So the minus 4 plus the 4 is 0, so 0x, which is what I wanted. 8 plus 2 gives you 10y. Minus 12 minus 3 gives you minus 15z. And on the right-hand side, we have a minus 40. And I got the 0. That's what I need to get here. If you don't get the 0, you're not doing it right. So this is my equation, minus 4 times the first equation plus the third one. So I'm just going to take it and substitute it back. Now, again, I didn't need to work this on the right-hand side. But it's just we want a way to minimize algebra mistakes. So that's what we have. That's minus 4 times the first equation added to the third equation. Notice I do have my 0 here. So again, let's check out what we have. There's the 1 up here. That once it's a 1, leave it alone. It does never change. It doesn't change. I have it's a 0x there and a 0y there. Notice how the system of equations, the 3 equations, keep getting simpler. They keep getting easier. The form gets nicer as we go forward. Okay, now what Gauss wants us to do is get a 1 in this slot, right? We had a 1 in the x slot in the first equation. Now we want a 1 in the second equation. Now how can we get a 1 there? You have any ideas? Think about it a second. How can we get a 1 there? Now the easiest way is to, right? You can pause and think about it. I'd like you to try. The easiest way would just be to divide everything by 9. And again, you can do that, but notice how you have fractions everywhere. Again, if it was on a computer, I wouldn't really worry about it, but I don't like to carry around fractions like that if I can avoid it easily, and we can. So any other way you can get rid of the 1 up there? You have a 10 and a 9, so there's some potential there, right? So again, if you can, think of what you want to try. Right, there's the 10 here, right? So I have a 10 and I'm going to swap their order, see? And now I'll just subtract, right? Subtract the third equation from the first equation. Okay, so they're just some of these features that come up if you're looking for it. And that's all I'm trying to do in this video is to introduce you to the ideas. So here I have it. I'm just going to bring that over. And I'm just going to bring this one over, right? And now what I'm going to do is I'm going to subtract these two. Right, I'm going to subtract these two. And this is what I get. So 10 minus 9 is 1. Minus 15 minus 10, right, is minus 15 plus 10 is minus 5. I'm subtracting these. And over here, minus 11. So I got the 1 there. That's what I was looking for. So now I'm going to take this and replace the second equation. Right? So really the second equation is just take minus 1 times the third equation and add it to the second equation. Okay, and I got the 1 right there. So notice I have the 1 here and a 1 there. Now I didn't introduce any fractions so far. Again, if you're doing this by hand, that's a good feature. And there's the 9 there. So now what Gauss wants me to do is get rid of this one, right? In other words, try to get a 0 there. Any way you can do it? Can you figure out how to do that? Give it a second. Try to, how am I going to turn that 9 into a 0? I'll take minus 9 times. Notice how I keep using this 1. Once I get this 1, I keep using it to eliminate other variables, to right, just like this. I'll take minus 9 times the first equation, and I get this, right? So minus 9 times the 1 is minus 9. Minus 9 times the minus 5 is 45. And you can see there's just a lot of opportunity to make algebra mistakes. I mean, I almost never do this correct the first time. Minus 9 times minus 11 is 99. Bring over the third equation. Add these two together. Right? And I get this. So in the y variable, minus 9 plus 9 is 0. 45 minus 10 is 35. 99 minus 29 is 70. So there we have it. I got the 0 there. So now I'm going to take this and replace the third equation with it. Right? And so I put that in there. And look how the system has gotten easier. Can you see why Gauss works? Look how the system has gotten easier and easier. Okay? It just, again, we'll talk about what Gauss is, but the system keeps getting easier each time we do this. So I have a 1 here, I have a 1 here, and I had a typo on the last one, but I need to have this 35 here. I need to get rid of that. So do you see a way to do that? And that's pretty straightforward. I'm just going to divide everything by 35, right? So we'll divide everything by 35 here, right? And we get, right, 1 and 2. 1 equals 2. Put that over. Now this is the kind of thing you should be aware of. See how I had 35z here equals 70? When you make an algebra mistake, and these are homework problems, they're no crazy fractions. So like if I had made an algebra mistake and that was 71, it wouldn't divide cleanly. The answer isn't going to be z equals 71 over 35. So if you start getting really crazy fractions, go back and check your work. Now I'm going to show you how to do this, but that's a good indication you made an algebra mistake. So if you start getting really crazy things, so if that didn't come down to be a 70 and a 35 there, I knew there was a mistake because there's no way you're going to have something crazy there. So I have a 1 here. Check. Right? So look how the system has gotten easier. Each time we do this, the system is easier. Now I have a 1 here, a 1 here, and a 1 here. Now I'll use these ones to eliminate other terms. That's looking good, right? So the next thing Gauss tells me to do, again, it's a very specialized order. If other things that we eliminated come back, that's not right. We'll talk about it. But it's a very specialized order how you go about this. And again, you can get very good at this. Okay, I need to get rid of that -5 and make a 0 there. So how can I do that? Do you see a way to do that? Try it. Okay, so I'm going to take 5 times the third one, right? See, that's going to give me 5 equals 10. I can use that, and I'm going to add it to this one, right? I'm going to add it to that, and look how this works. Add them together, and okay, 1y adds to, nothing. -5 and 5 is 0, z, and over here -1. And I got the 0 where I wanted. So I'm going to substitute this one back up here. And look how everything is getting easier. Look at this. Look how this system of equations is just melting away, right? I mean, this is the idea. Each time we do the process, it gets easier. So I have my 1s. Notice they have to stay. Okay. Now what Gauss tells me to do, again, look how simple this is getting. Now Gauss tells me next to get rid of this 3. So can you see how we're going to do it? Try to write down a step. See if you know how to do this. I'm going to make that a 0. Okay, try to write down a step. I have this 1 here. Notice I always have this 1 here to work with. I'm going to use this 1 to get rid of that 3. That's going to be a theme. So I'll take -3 times the last equation. See, that gives me -3z. And I'm going to add it to the first equation. Add the 2 together. And it comes out nicely, right? 1x minus 2y. Now -3z. 3z minus 3z is 0. Z, right? And then on the right-hand side, 5. So that's it. I have my 0 there. And I'm going to substitute that back up. Right? And now look, it got easier. Every time we do this, pieces are just melting away. 1, 1, 1. I need to make sure I don't mess it up in the way. Now I need to get rid of this -2. Okay, do you see how I'm going to do that? Take a minute and try. I have that 1 there. I have that 1 there. I have that 1 there. Right? You're going to use the 1. You always use the 1s. So times this equation by 2. Right? You see I have a 2y now. And add to the first equation. Right? Add these together. And look what I get. The 1x just comes down. The -2y and the 2y is 0. Y. And then on the right I have 3. I have my 0. Now I'll put that back in there. And look at this. Look how, this is why Gauss works. Again, it's an algorithm for doing this efficiently. 1, 1, 1 is what I want. So when I went back to the original problem, I had a system of equations, 3 equations and 3 unknowns. And I wanted to know what the x, y, and z variable are that make all these equations true at the same time. Not just one, all of them at the same time. Right? And then, so what did we do? We needed an algorithm. We used Gauss Jordan elimination. Now what's remarkable about Gauss Jordan elimination is the top problem has a solution set. Has, let's say, one and only one solution. Right? We said one and only one solution, an x, y, and z value. Well, when we do the Gauss Jordan elimination, the system changes form, but the solutions never change. So the system at the bottom here, that's a system of 3 equations and 3 unknowns, has exactly the same x, y, and z solution as the top. And that's what's remarkable. Same solutions. That's what Gauss does. It doesn't change the solutions. I mean, that's amazing. Yeah, mind blown. So I wonder in the bottoming system of equations, possibly what could x be? I'm just saying, if I had to guess what x was, I mean, what could 2, 6, 0? How about y? Could you figure out what y is from this bottom one? I mean, you know, z, I don't know. I'm guessing in the top one, if I substitute x as 3, 3 equals 3 would work. I'm just saying. In the bottom, I'm guessing if y was minus 1, you'd get minus 1 equals minus 1, and that would work. In the third one, I'm guessing if I took z to be 2, 2 would equal 2. I mean, it's not trivial. That's how easy this is. So if I take x equals 3 and substitute it into the first one, into the top system, y equals minus 1, and z equals 2, it works. You get 4 equals 4 in the top one. If you do all this, you're going to get 4 equals 4 in the second one. And if you do all this out, you get 11 equals. So it works. You can always check your answers here. That's the thing. So if you plug yours in and it doesn't work like that, you made an algebra mistake. You need to go back through those steps. Don't start from scratch. We'll show it just to show your work, and you'll get it to work. Okay, so that's it. We convert the top system to the bottom system, which is easy to solve. Like, you can't guess x, y, and z in the top one. We convert the top one to the bottom one, and that's nice. Okay, so that's all I'm going to do for this one. Now, in the next video, we're going to do this in a more systematic way. Still not the final form, but it's too much trouble carrying all this baggage around. So in the next video, we're going to start actually looking at more of the shorthand notation. Okay, so see you then.